ampere characteristic of a known device D, which is connected in a circuit in series with a resistance, and a battery is shown in the figure. The value of resistance is given, and the terminal voltage of the battery, that is also given, 5 kilovolt. You have to find out the potential drop across the device. What should be the potential drop across the device? Now, to begin with, if you look into the problem, there are two behaviors which we can look into. First of all, let's say the V0 voltage is 5 kilovolt, that is given. Resistance here is 300 kilo ohms. Okay. If you look into I versus V character, to begin with, it behaves like a ohmic person, ohmic resistor. But after a current of 10 ampere, right, 10 milliampere, the voltage is becoming a constant. So for whatever value of voltage, the current cannot exceed a value of 10 milliampere. That is given to you. क्या रहा है शुभम? 2 kilovolt is actually the correct result. क्या लिख रहे हैं for the device? What are you saying? So you are solving for a value of 10 milliampere. है ना? So let us solve for a data where I comes out to be 10 milliampere. We will check gradually. So for 10 milliampere, the drop that you are getting, that is 300 into 10 raised to the power 3 into resistance, that is current, 10 into 10 raised to the power minus 3. So you are getting what? 3000. So 3 kilovolt, right? So for a V0 of 5 kilovolt, I am getting a voltage of 3 kilovolt across this device. Seems to be that at this value, this is 2 kilovolt. Fine. May not be the final answer only. So we need to check also. और कोई कंडीशन इसमें नहीं आ सकता? This is the only thing. हाँ, चेक करना पड़ेगा. तो चेक क्या करना चाहिए? प्रथम आपका बात सुनते हैं. This is fine that you assume that the voltage, the answer to the voltage across this device, let's say we just solved for some value 10 milliampere and we got a value which is lying in that domain. That means our assumption seems correct. That is fine because I got a value of 3 kilovolt, right? Now, one more possibility is that actually I don't have a current. I mean, this voltage is less than 1 and I'm in this domain. So for that, what can I say? Is that a possibility in this problem? Is there a possibility that I may have something which is lying in this domain somewhere here? Bolo. And is that coming out to be greater than 10? So this domain can be verified because for voltage across device, this is just a verification that I want to do and verify. If the voltage across the device comes out to be less than 1 kilovolt, so that means the voltage across resistance that is greater than 4 kilovolt. That means the current across the resistance is greater than 4 kilovolt upon 300 kilo ohms. What is that? 4 upon 300 is greater than 4 upon 300. And because we are writing, so into 1000 milliampere. What is this value coming out as? 40 by 3. Yeah? So 10 point something, and that is greater. So there is a contradiction here. So we'll leave the result. Fine. Let us move on to the next problem. That is RC conceptual problem. Take question number 24-25. इसको हटा देते हैं. Should I remove it? वही किया बट द वैल्यूज, दो वैल्यू बहुत सिंपल है ना, दो ही बातें हैं, या तो करंट 10 मिली एम्पियर से इट इज लेस देन 10 मिली एम्पियर, इट इज ग्रेटर देन 10 मिली एम्पियर. सो आई सॉल्व फॉर अ कॉम्बिनेशन वेयर मतलब 10 मिली एम्प this state is prevalent na, that is what I'm solving for. If this state is present, I'm solving for some voltage which is greater than 1 kilovolt. I got one value, so that is one answer. Then the only check should be, is there a possibility here? वैसे तो from values I knew that there is no possibility. Just for a subjective check, I'm finding out that those values are not possible. Okay, because the second question is also there on this page only. So try question number 7. Again, the V versus I characteristic of a nonlinear device and a corresponding circuit used are shown in the figure. Now, voltage VB of the battery is made to vary. This is information which you have to be analyzing carefully. Voltage VB of the battery is made to vary. This is the variable voltage, okay, from 0 to 30 volt. And V1 across the device D, voltage V2 across the 10 ohm resistor, and the current I supplied by the battery are measured by ideal voltmeters V1 and V2 and ideal ammeter. वो सब दिया हो. Now, which of the following graph or graphs represent the correct relationship? Just to, represent these graphs correctly, these lines, the key points are like this, right? There is a non-differentiability point here. This is straightforward, 1 pixel by 1 pixel. Here also, if you observe, the values are different, not crossing any standard point. But in this case here, these are the values and then straight line. This is the point of non-differentiability. Here also, this is the point. I think now you can observe the values carefully. So check which of the following options are correct. तो nonlinear device जो है उससे काफी clarity है. You need to begin with, again, it is behaving like a ohmic device. Then after, that means whatever be the value of current after a subtle stage, its voltage is fixed at 5 for the device. Battery voltage is 5. So these values you can use when you are varying it from 0 volt to 30 volt. You can use these values. So any one information through which you can start solving it, like just look into any diagram, just say V2 versus I. This seems to be the slope kind of characteristic of this person. The only thing is the current is not in this person, no? But these voltmeters are ideal. So actually, this graph is basically talking about the resistance 10 ohm. है ना? So iska agar V versus I, if you sit here, you should see that the slope of this person should be 10. So this value is 30. This is perfectly fine. This value is 30 and here it is 3. This talks about the resistance. So no hassle with B option. Okay. As far as the values are concerned, let us check also and try to understand. It is not mandatory that he is going through all the values, because basically you have not applied any voltage which is greater than 30. So even if this device D keeps some voltage with himself, the 10 ohm guy cannot have a 30. So I'm not saying that it is possessing all the values, but it is a straight line and slope is constant, so that graph is correct. So ये तो बात सही है, right? Now you can look into V battery and the current function or any easier function. All the functions are now with respect to the battery. Let's talk about D option. Let's check the D option first. D option. Battery voltage you can vary from 0 to 30. How do you expect this current to vary? Because on the basis of current you can answer, na? उसने तो V2 को बताया, V2 is I into R. So is D option for 0 to 5 or 0 to 5 of that person? You understand this point, no? Is D coming out to be correct? Kaise, Piyush, yeah. So you are saying up to 15 volt, it will follow one pattern. और VB check कर लेते हैं. और 0 less than equal to VB less than equal to 15. Let's see what characteristic will that follow. That means you are saying the voltage that you are getting across 10 ohm, that is behaving from 0 to 50, but 0 to 10. Why? So after 5, everything is fine. So after it acquires a voltage of 5, that is the device. So basically, after that, it doesn't change the voltage. So that means this person will have a value of what? What is that value after which it will increase? Character-wise, I am convinced. My only concern is for 15 less than equal to VB less than equal to 30. I want to see the variation also, the function. VB minus 5 afterwards. तो उसको तो 5 से बदलेगा नहीं. तो ये function तो VB minus 5 है. And I'm talking about the voltage V2. V2 is what I want to write. And to begin with, what is the value? V2 should be equal to 2 by 3. Yeah. वो डायरेक्टली भी बोल सकते हैं यार, क्योंकि इसका कैरेक्टर लीनियर है. सो यू नो द वैल्यू ऑफ करंट and current into resistance will be the voltage. Because this person is always having a resistance of 10. The only thing required is the current function. Current function of this person and the 10 ohm person is the same. So current का function है क्या वैसे? What is I? इसका current का function क्या था? So I will come out as 2 by 5 times V of this box. Is that fine? So 2 by 5 times V of the device is the current through the device, right? And this current into 10. So 2 by 5 times V device. Is that fine? हाँ, मतलब हम लिख लेंगे वो, बट बैटरी और उसका वोल्टेज के क्रॉस तो हम रिलेशन लिख ही लेंगे. बट विथ रिस्पेक्ट टू द डिवाइस V2 कैन बी रिटन लाइक दिस. एंड अब डिवाइस का आपने जो अप्लाई किया उसके साथ लिखना चाहते हो, सो हाउ कैन वी राइट? हाँ, मतलब ठीक है, वो डायरेक्टली भी लिख सकते हैं क्योंकि वो आई के साथ भी लिख सकते हैं. ठीक है ना, सिंपल है इतना. द मैटर ऑफ फैक्ट इज, फिर से बोल देते हैं कि फॉर अप टू द वैल्यू ऑफ 5 वोल्ट it is behaving like a resistor only. So practically for the total supply till he gets 5 volt, he is acting like a resistor. And if he acts like a resistor, his resistance is coming out as 5 volts. So that way you can distribute it, and afterwards it has become a constant voltage. That value is 5. So whatever you supply after that, he will take a fixed voltage and remaining voltage will be linearly distributed. You check the values, otherwise we can find out. Yeah, ठीक है? Now, tell me the A or the C part. C part seems simple. C can be answered. V1 versus VB. Again, from the same values, it can help up to 15. If you got this value here, 15, up to a value of 15, V1 and VB, they are having a linear characteristic. है ना? क्योंकि वो तो रेजिस्टेंस की तरह ही बिहेव कर रहा होगा. तो क्या V1 आ रहा होगा? करंट VB के साथ उसका बिहेवियर क्या हो रहा होगा? What is V1 in this domain? So VB by 3 ना? It's fine ना? It should be VB upon net resistance, and the resistance that you have bought is 15 into uska resistance, and that value is 5. So basically VB by 3. That's what I'm getting. And so you can check VB by 3. And after that, whatever is VB, this voltage becomes fine. So fine. This is also fine. This is also. No hassle in finding out this value also, no? All good up to this stage. So, ठीक है, VB by 330 to 10. All good up to this. Just check the A option now. Just check. Again, values are quite clear. Up to 15, it is having a linear characteristic. So again, I can directly say that up to this value, it is linear. And what is the value of I with VB? So I think this domain, the value should be I is equal to VB upon net resistance, which is 15. That is it. After that, VB versus I. So after that, I should say, I mean, in this domain, my equation should be like what? VB minus 5 is what I will apply by 10. That should be the current I. If you check, I think you will get these values after 50. और वो 15 आपको मिल ही रहा है क्योंकि 3 ऑल गुड A, B, C and D all seem correct. आगे चले. Pick up the next problem, which was on a RC combination. So take the question number 16. I'll make it. Pick question number 16. The figure shows part of a large network in which potential of some of the points are shown. Each capacitor has capacitance of 5 microfarad. Which of the following statements are true? All the capacitances are 5 microfarad. Potentials are known. So which statements are true? Check. First is, from the given information, the potential of O can be determined, but that of B cannot be determined. पहले तो यही find out कर लेते हैं. And B option, if you read both the things, that will give you a complete feel. From the given information, potential of both points O and B cannot be determined. So what are the key equations I can write and comment? Just think. Assume some voltages and then you can make the comments. So because 0 he has already taken at this point, so you can take some values. Let's say voltage here is A volt, and let's take the voltage here as B volts. Let's see. Right? So, first of all, we are trying to solve this problem. First of all, let's be very clear that he is considering this problem at t tending to infinity. If he is talking about I will answer both the things. Transient state also I will answer. But if he is discussing the problem at steady state, what is that we can tell? So generally, from the basic information, assuming that all the initial states were 0, and this is the final state. So there is a loop where the net charge should be 0. So seems like A minus B का एक term है drop. Then because current is not flowing, so this point will be at 10 volts. So I'm having a A minus 10 drop. I'm having a A minus 10 drop. And I'm having a A minus 0 drop. I'm just taking all the C's together, right? They are given and make it equal to 0. So through this loop, right, I can write one equation carefully by conservation of that charge. So I mean, we can write that equation between A and B, but nothing more than that. If you look into this equation, what are the terms you are getting? You are getting a 4A term, then you are having a minus B term. So 4A term aa raha hai, minus B term I am getting. That is coming out as 0. Yep. So there is a relation between A and B. So when he says the potential of both O and B cannot be determined, that seems correct. दोनों तो नहीं आ रहे. Potential of this is not, that is not right. Data is not complete to find out. We can write an equation that seems fine. और ये भी कह रहा है, if the charge on capacitor C2 was specified, potential of O can be determined. But that of B, no, that is wrong. If any one charge was specified here, I could have solved no problem because C was already known. So that is not right. C option is incorrect in the problem. Just read D now. If the charge on C2 were also specified, okay, potential of, that seems perfectly fine. D option seems correct. So as far as this RC is concerned, B and D seem to be the correct result. Okay, chale. Acha, if this problem pertains to the state, general T is equal to T state, then there will be a problem because there can be some current through the resistance R, and then even this equation will be withheld. Ya to current bata de, otherwise we will end up with 3 variables. Because whatever current is there otherwise, that is not required, but this expression is needed. Then I will have 3 variables. So even if you provide that charge, still I will be stuck. You got your mind? Tab to fir phas jaye. So it is better that he would have specified that he is talking in the steady state of the problem. Okay. Pick up this problem number 19. Again, a multi-correct problem. So you have to be careful. In the circuit shown, the device D has a property that if initially non-conducting, it remains non-conducting until voltage across it rises to a value V1, which is less than V0. So tab tak to non-conducting rehta hai. And it then rapidly discharges the capacitor until the voltage across it drops to a negligibly small value, whereupon it returns to a non-conducting stage and the voltage, so again it will charge. So can you tell me the periodicity, the voltage developed across the capacitor is? He has already mentioned that up to a value which is less than, which is V1, and V1 less than V0, it remains non-conducting. So basically, it behaves like an open circuited wire. And then at that very instance, when it attains a voltage of V1, it discharges suddenly. Rapidly discharges, and value attains nearly 0 value. So if you draw the RC Q versus T graph, also you'll get your result. Getting it? What is coming out to be the correct result? C is, yeah. Because simply I can say the voltage across the capacitor as function of time, Vc, if I want to write, it is V0 into 1 minus e raised to the power minus t by tau. Tau value here is RC. This is for Vc from 0 up to a value which is V1. This function is followed. So as soon as it acquires a value of V1, it will take some time. So if I just try to draw the graph, it seems like from 0, it was trying to go towards this value, V0, but exactly when it acquires a V1 value, then it suddenly discharges. And then this kind of pattern is being followed. This time gap is low. So this is the periodicity we are talking about. This is what we are talking about. So I think if you find out this T here, you should get, and when you solve it, it comes out to be C. Now let us change this problem a bit to a multi-correct paragraph type problem. Just look into this RC where some electro concepts are also being added. So look into question number 24 and 25. Here he talks about two electrically neutral conducting thin spherical shells of radius r and 3r. A particle of positive charge capital Q that is fixed at a distance of 2r from the common center of the shells. That is given. Now what is the question? The inner shell can be electrically connected to the outer shell through a resistance R1 with the help of a switch S1. And the outer shell can be grounded through a resistance R2 with the help of another switch S2. So a connection between inner and outer, that is through S1 with the help of a resistance R1. And outer can be grounded with resistance R2. Those switches are being given now. Now here is the first problem. How much total heat is dissipated in R1 after the switch S1 is kept closed, keeping the switch S2 open until a steady state is reached? So draw this circuit and let's try to find out the amount of heat which is being generated. See, in the first part. Remember, a capital Q charge is also being kept at a distance of 2r from the center. And if you look into the initial state, when you are starting the problem, when you are closing the switch, there doesn't seem, I mean, if I draw this separately, just to show you the initial state, I'm redrawing the circuit. Outer person is not even connected. So your circuit is like this. I mean, state is like this. There is a plus Q charge which is fixed here. And this distance from the center comes out as 2r. This radius is r. This radius is 3r. Nothing else is connected. Seems like here it will be 0, 0. Here it will be minus q and some positive q charge. ठीक बात है? So this is already present. Now you close the switch. So we start the problem from this part only. Let us connect a switch here through a resistance and let us try to close it. This resistance is R1 and the switch is S1. Connect the inner and the outer person with the help of a conducting wire. Now you have to observe the final state in the problem. If we want, we can also analyze a general state, but I don't think we want to write the function. We can write the energy or the heat generated directly. So try to write that function. What I'm trying to say is, if this is my initial state, so I'm using different colors for the different states. Initial state is given. I'm in this problem only, I want to write the general T is equal to T state, the general state T is equal to T. Right? At this stage, because at this stage, what are the charges we can write? So let's see. We think we can write a charge 0 here. There may be some Q here. Or इसके ऊपर आ जाएगा. So this total is plus Q. So minus small q minus capital Q here. This is the capital Q charge. And what was the total of inner and outer? That was 0. So capital Q here on the outer surface by conservation of charge. Remember, Q is some function of time. And whatever function you need, I'll write afterwards. Let me write the final stage now, final stage. So those values we can directly convey. Let's see. Because finally both the voltages will be equal, inner and the outer voltages. Yeah. So I'm writing final values as 0 I'm taking some Q naught, Q का value, some Q naught, minus Q naught, minus capital Q, and this value seems to be capital Q. Right? So first of all, in the final state, solve for Q naught. Try to find out what is the value of Q naught. Then we'll see what is Q naught coming out as. Because the potential of both the person are equal. So what is Q naught? In the final stage, just give me the value of Q naught by the static condition. While writing the potential on the outermost surface, all these inner cavity elements will be redundant. So capital Q is the only person who will generate field. So it seems like K capital Q upon 3R. And what about the inner potential at that stage? कितना? That will be the potential of the inner surface. The net potential of the inner surface is what I want all of you to write. Yeah. इसे लिखो. हाँ, sure. क्या बोला? That value, small Q naught, which I have written, I want. एक बार वो एक्सप्रेशन बता दो, Q naught कितना निकला? और जो चार्ज अलग से रखा हुआ है प्लस कैपिटल क्यू को डिस्ट्रीब्यूट किया एक स्फेरिकल फॉर्म में, कैसे, मतलब वो बन जाना चाहता हूं. हाँ, इनिशियल स्टेट पे तो लिख सकते हैं, ठीक है. ओके, नहीं, एक तो बहुत स्ट्रेट फॉरवर्ड है. इफ यू टेल मी द फाइनल चार्ज किसी भी रास्ते से आप बता दो, तो मुझे Q के टर्म्स में फंक्शन दिख रहा है, मतलब आई कैन राइट द पोटेंशियल ड्रॉप देयर एंड I'll just integrate Q from the initial value was 0 to Q naught, क्योंकि जो डिफरेंस है वो तो मुझे दिख ही रहा है. व्हाट इज दैट VB माइनस VC? तुम्हारा जनरल VB माइनस VC क्या आ रहा है, जनरल फंक्शन? Because my interest, while I am finding out this heat, I am very clear. The answer to the problem is I just want to integrate Q from 0 to Q is equal to Q naught, and there will be a dq flow that will happen, and I'll write the potential drop. So this is the general function only which you will make equal to 0 while writing the result. Polarity you can take care of, but general state में potential function एक बार VB minus VC मैं देखना चाहता हूं क्या आपका निकल के आ रहा है. You are getting K capital Q by 6R term, and you are getting a 2 by 3 times KQ by small r terms, है ना? हाँ, विशा कैसे आ रहा है वो टर्म्स वो बताओ. इसी का फाइनल लिख लेते हैं पहले. हाँ, फाइनल ही बताना क्या लिखा. जनरली यू कैन एक्सप्लेन, मतलब जनरली बताना मुझे इन येलो टर्म्स में से कौन कौन से टर्म आपने यहाँ लिखा एक एक. So that is KQ naught by. So the terms that you have written, I'll just try to write it immediately. So K term I have got a Q naught upon smaller term. Yeah, then capital Q by 2R at inner point. You're writing capital Q term by 2R term. Yeah, then why plus term here? ये तो नहीं, ये तो बस कितना बन रहा है, माइनस Q naught ना. and that you are writing as minus q naught by 3r. So you're writing minus q naught term by 3r. ये लिख रहे हो? Plus minus q naught minus capital Q. Just check कर लो एक बार before you prepare. This fine? Check all the terms carefully. And the same thing you have to write as difference at general T is equal to T, at general R is equal to R. On the outer surface, fine, it is K capital Q by 3 times small r. On the inner surface, look into all the terms carefully. So K Q naught term in the final state by R, that is fine. Capital Q का effect वहां लिखा है अंदर वाले point पर, that is coming out as 2R, right? और जो last वाला surface लिखा है minus Q naught minus Q, that is divided by 3R. So from this, while you solve, what is the value of Q naught you are getting from here? Minus capital Q by 4, minus capital Q by 4. Now everything is fine because this Q naught will become minus capital Q by 4. I'll take the mod of this expression, that's fine. And now just write the potential drop down. Same expression which we have written earlier, write the same expression. The second approach, the one thing is this, if we want to write the potential drop this way, अगर हम इसको capacitance की तरह देख लें, तो again we can write the answer. Just a moment. अब शुभम बोलो, क्या बोल रहे हो? हाँ, तो कैपिटल Q को दोनों सरफेसेस के ऊपर डिस्ट्रीब्यूट कैसे किया है? तो वही मैं बोल रहा हूँ, उस कैपिटल Q को अगर आप डिस्ट्रीब्यूट कर लो किसी स्फेरिकल शेल के जैसे, मतलब यू कैन मेक अ हाइपोथेटिकल स्फेरिकल शेल देयर और उसको डिस्ट्रीब्यूट कर सकते हैं इनर सरफेस और आउटर सरफेस पे, देन टू लुक इनटू दिस प्रॉब्लम एज अ स्फेरिकल कैपेसिटर विल बिकम इवन इजियर. या जो बात आप बोल रहे हो कि बिकॉज ओनली बिकॉज ऑफ दिस स्पेसिफिक चार्ज दैट पोटेंशियल ड्रॉप विच वी आर राइटिंग इज अ कांस्टेंट, है ना? तो उसकी वजह से जो खुद का आ रहा है वो अंदर वाले सरफेस के ऊपर एक कांस्टेंट की तरह आ रहा है, जो आप लोगों ने भी लिखा है KQ by 2R. मतलब अगर इसमें भी देखें तो हम वही लिख रहे हैं, स्पेसिफिकली अलग अलग चार्जेस के लिए लिख रहे हैं. कैपिटल Q का अंदर वाले पॉइंट पे लिखा, दैट कम्स आउट एज कैपिटल Q by 2R. इसका लिखा ऑन द सेम सरफेस, दैट इज ऑल्सो फाइन. दिस आउटर सरफेस चार्ज ऑल्सो वी आर राइटिंग देयर ऑन द इनर surface in the final state. What about capital Q in the final stage, the last surface? हाँ, मतलब बेसिकली पॉइंट है कि डिफरेंस लिख रहे हैं, ओ ये लिख रहे हैं ना. मतलब अल्टीमेटली अलग अलग देखने की जगह बेटर होता है कि आप इस सरफेस से इस सरफेस तक का जिसका भी डिफरेंस में कंट्रीब्यूशन है वो देख लेते हैं एंड जस्ट मेक द डिफरेंस इक्वल टू 0 इन द फाइनल स्टेज. So that region was concretely governed, क्योंकि जब आप बोल रहे हो कि capital Q is providing a constant on the inner surface as well as the outer surface, things are fine. क्योंकि जो भी वेरिएशन है वो दो ही चार्जेस का है जो उसी डोमेन में बैठे हुए हैं, that is that small q and minus small q minus capital Q. और इसका डिफरेंस एक फिक्स टाइप का कुछ मुझे मिल रहा है, ये वेरिएशन दे रहा है मुझे R के साथ. That's what I am saying, है ना? एक R के साथ कुछ वेरिएशन प्रोवाइड कर रहा है और एक कांस्टेंट डिफरेंस प्रोवाइड कर रहा है, जो कैपिटल Q का चार्ज है वो कांस्टेंट डिफरेंस देता है. तो मैं ये लिख रहा हूं कि अगर मुझे मैग्नीट्यूड ही चाहिए था तो यहाँ पर मुझे मॉड टर्म से भी काम बन जाएगा। एक बार एक्सप्रेशन देखा क्या बन रहा है आपका, खत्म करते हैं फिर इसको। So that is becoming K capital Q by 6 times small r minus 2 by 3 times K small q by small r. Check that. बढ़िया है, तो मुझे दिए हुए थे, मेरा काम बन जाना चाहिए। वो डिफरेंस Q के ऊपर डिपेंड करता है, मैंने लिख दिया। और Q को आप मैग्नीट्यूड ले लेना। आई थिंक यू शुड गेट योर रिजल्ट फॉर क्वेश्चन नंबर 24, द फर्स्ट वन। आगे चलें। Now the problem is when a steady state is reached after closing the switch S1, that state you already know. The other switch is also closed now, S2. The question is how much total heat is dissipated after S2 is closed until a new steady state is reached. So that is basically the effect of S2 on the problem. तो solve करना, जरा देखते हैं। ये हटा दूं पूरा द सेगमेंट, सॉल्व इट। योर फर्स्ट स्टेडी स्टेट इज नोन इन द प्रॉब्लम। वहीं से आप प्रॉब्लम को स्टार्ट कर लो। यू नो द इनिशियल चार्जेस नाउ, दोस क्यू नॉट वैल्यूज, कैपिटल क्यू वैल्यूज। आई विल रिमूव दिस। नाउ यू इनिशिएट योर प्रॉब्लम। सो योर जीरो स्टेट फॉर दिस प्रॉब्लम इज, फिर डिफाइन कर लेते हैं। We have to only find out the effect of S2 on the problem. So draw that state and try to find out the heat which is dissipated in both the resistors. Calculate it. Let's see. 24th का रिजल्ट क्या निकल के आ रहा है आप लोगों का? C, fine. That is correct. That was correct. 25th. Few things we can directly mention in the problem, है ना? जैसे कुछ ऑप्शन तो डायरेक्टली बन रहे हैं। जैसे डू यू थिंक इन दिस प्रॉब्लम अगेन इफ द आउटर शेल इज कनेक्टेड, इनर ones are connected through R1, बाहर वाले सरफेस को फर्दर स्टेडी स्टेट से कनेक्ट कर दिया विथ R2, and inner one is not going to produce anything, so no heat is dissipated in R1 seems correct. तो A मुझे ठीक नहीं लगता, मुझे D भी ठीक नहीं लग रहा। both the resistors dissipate different amounts of heat, right? Now ये तो वैसे ही गलत लग रहा है, heat dissipate, मतलब this seems incorrect. I think if something has to be thought upon, it is only C that we should check. Check the value of heat. This will be in both the combination. In fact, I don't even need to calculate it now. Directly बोल सकते हैं. What is the value of charge that you had on the outer surface there? मैंने कैलकुलेट नहीं किया था. What was the value? Outer surface. Okay, right. So how much heat are we dissipating from R2? Are we dissipating any heat from R1? नहीं, R2 से ही देख रहे हैं. R2 से कितना डिसिपेट करेंगे वो देख लेते हैं. सारा चार्ज जा सकता है ना. R1 से कैसे फ्लो करेगा, क्योंकि अंदर तो कोई चेंज हो ही नहीं. इनडायरेक्टली आपने सिर्फ जो S2 वाला आउटर सरफेस है उसको जाके अर्थ कर दिया फर्दर. इनर एक स्टेडी स्टेट मेंटेन थी, मतलब हाँ, आप यही चीज तो मैं चाहता हूँ इस प्रॉब्लम में. मुझे इनिशियल स्टेट आप बता दो क्या क्या आपको दिख रही है. आपको प्लस कैपिटल क्यू फिक्स दिख रहा है एट अ डिस्टेंस ऑफ ट्वाइस ऑफ आर. यू जस्ट टेल मी द चार्जेस जो हमने निकाले थे. मुझे एग्जैक्ट वैल्यू बताओ क्या था, मुझे साइन के साथ बताना. सो दिस वैल्यू वाज 0 हियर. व्हाट वाज दिस मैग्नीट्यूड हियर विद साइन? minus capital Q by 4. You got a value here. It was Q minus Q by 4, 3Q by 4. So you got minus 3Q by 4 here. Minus 3Q by 4 was prevalent here. And what was the last surface? Q. Q. So their total was coming out in this problem. We had not given any charge to these people. So effective charge that was coming out as 0. So now you can start the problem. There is a resistor. Think this is the state. There is a resistance R1 which is connected between these two people. R1 connected है. And effectively you are also connecting a R2 which is connecting this person to a earth state. You're closing the switch. So as such, you have disturbed the circuit. The outer one is also earthed. Now we need to find out the heat which will be dissipated in both of them. Check now. शुभम अब क्या बोलना चाहते हो बोलो. हाँ ठीक है. जो इसकी नई फाइनल स्टेट आएगी, अब ये प्रॉब्लम के लिए इनिशियल स्टेट है. यहां से जो फाइनल स्टेट आएगी जब सारा वो बस एक बार वो ड्रॉ कर दो तो वी कैन इजिली नाउ आंसर. जस्ट ड्रॉ दैट फाइनल स्टेट. Both of them will be earthed down, right? What are the charges you can see? You have got a zero charge here. Outermost also will be zero. है ना? So what is it? I'll have a charge x here maybe. So I'm also having a charge which is minus x minus q which is present here. So just find out the value of x right now. बस अंदर वाले का net potential zero कर दो. So what are we getting? This radius is r ना, and this is 3r. So x का value final stage जो अब आ रहा है इससे you have to find out the value of x. Let's see what is the value of x you are getting. If I write the potential at the inner surface and make it equal to 0. Outer one I have already made equal to 0, so I got the last surface charge as 0. X का वैल्यू आ रहा है 5q/4. Yeah? So in the final state, your x is coming out. All of you just check this value. I'll write the equation. People can solve it. Terms बताओ मुझे शुभम. When you are writing the terms, क्या क्या अंदर वाले surface पे लिख रहे हो आप? माइनस q/4 आ रहा है. The value that you are getting is actually minus q/4. क्या क्या टर्म्स लिखे एक बार बस इक्वेशन के टर्म्स बता दो क्या क्या लिखा है. वो हटा देते हैं. मेन चीज क्या क्या. ओके एक्स बाय आर टर्म लिखा है. ठीक है. क्यू बाय कैपिटल क्यू बाय 2r इज फाइन. हाँ ठीक है. ठीक लग रहा है. सो यू आर राइटिंग x बाय ट्वाइस ऑफ r. यू आर राइटिंग कैपिटल q बाय ट्वाइस ऑफ r अगेन. हाँ x by r. x by r. Yeah. x by r on the surface. Then you are writing q by 2r का टर्म. और एक टर्म आपका आ रहा है माइनस एक्स माइनस क्यू डिवाइडेड बाय 3r एंड यू आर मेकिंग इट इक्वल टू 0. दैट इज हेल्पिंग यू आउट टू फाइंड आउट x. ये तो ठीक लग रहा है. अब फाइनल स्टेट में आपको सारे चार्जेस पता है एंड अगेन इट इज कमिंग आउट एज माइनस q/4. तो अब तो फिर सारी चीजें खत्म. सो दैट justifies this fact that no heat is dissipated. So अब निकाल दो कितना आया होगा. उसका स्टेडी स्टेट और उसका इनिशियल स्टेट आइडेंटिकल है तो उसमें तो फ्लो होता हुआ चार्ज नहीं दिखा. ये बात तो सही है ना. क्या लिखना चाहिए टर्म. ठीक लग रहा है, क्यू स्क्वायर अपॉन ट्वाइस ऑफ सी लग रहा है, और सी टर्म इसका 4 पाई एप्सिलॉन नॉट इंटू 3r आता हुआ दिख रहा है. What is the term coming? 24. That's fine. So I think C should be correct. D is incorrect. And because we have checked, verified it, कि अंदर वाला जो स्टेट है वो ठीक है, तो बस वो उसकी जो बाहर वाली एनर्जी है वो लिख दो, क्या प्रॉब्लम. डी में क्या है? बोथ द रेजिस्टर्स डिसिपेट डिफरेंट अमाउंट्स ऑफ हीट. अब डिफरेंट अमाउंट कहना बड़ी अजीब बात है, बिकॉज एक ने तो जीरो किया है. वो पता नहीं, लेट आईआईटी डिसाइड whether he will give only C or C or D. Because technically different amount doesn't make any sense because heat is not being generated. Look into question number 9 and find out the. Actually, he has given a VI characteristic in the problem, which is for an incandescent lamp, as shown in the adjoining figure. He has also said this lamp can withstand a maximum voltage of 3 volt and a maximum current of 0.4 ampere, 0.4 ampere and 3 volt. ग्राफ पे अगर आप देखो तो कुछ डेटा प्रॉपरली दिया हुआ है. आई मीन इफ यू लुक इनटू दिस इंफॉर्मेशन हियर, इट इज पर्टेनिंग टू 0.2 एम्पियर एंड 1 वोल्ट. ठीक है, सो इनिशियल कैरेक्टरिस्टिक अप टू अ गिवन वैल्यू मे बी इवन मोर देन 1 वोल्ट, somewhere here, somewhere between 1.3 1.4 तक, it seems like a ohmic body. Now the point is, many the infinite such resistors or bulbs are being connected in this circuit, and his question is simple. He has said that what maximum voltage can an external agent apply in this problem here. So what is the V max that he can apply? That is the question. It is more about the crisscross thinking and looking into the data appropriately. And ये भी बात सही है that if you look into the values, when it remains ohmic, मतलब मैं इतना बोल सकता हूँ, when it is ohmic, in that domain, it has got a resistance which comes out as what, 5 ohms? Yeah. That V by I value, so 1 upon 0.2, so 5 ohms है. जब ओमिक है तो 5 ohm. अब ये नहीं पता है कि when we apply the maximum voltage, which of them will behave in the ohmic manner. So that is the only thing which you have to apply. And one thing that comes to our mind directly from the problem is that this current, now there is a boundary on current also, and I know that at any cost I cannot go beyond 0.4, right? So to begin with, the thought that comes to my mind, and I can confirm everything, then that thought is that he is not behaving in an ohmic way, so he has got some resistance X, because it seems like that I will have some value which is very high. Maybe I can check with a value 0.4 also, I derive the inequality, don't worry. But this is the person who has got the maximum current. And it seems like that in between these points like C and B, if we can replace this body with a subtle resistance, let's say R prime, we don't know what is it, then the current through this first person, which is the highest current, that should be V upon, if my voltage is D, that is V upon X plus R prime, and that should be less than equal to 0.4 at any cost. If that is satisfied, then all the other people will obviously have less current. Also, I should write for the voltage, the second term. What is that second equation? This is the current equation. Net resistance लिख दिया. Normal मैंने net लिख दिया. Voltage is known to mu, and at this stage I don't know the resistance. कोई तो resistance होगा. ओम्स लॉ तो इंस्टेंस पे करेगा ही, बस तभी तो एक्स लिखा है, मुझे नहीं पता ना एक्स की वैल्यू क्या है। हर इंस्टेंस पे तो v इज इक्वल टू आई आर हो गई। द पॉइंट इज आई डोंट नो दैट वेदर दैट r इज कांस्टेंट और नॉट, दैट्स व्हाई आई हैव सेड ना इट हैज सम वैल्यू x, that x will be pertaining to the slope. I don't know the value of x here, but that inequality of 0.4 is coming. Similarly, I want to write an inequality for 3 also, 3, and write it for that. दो लोग हैं वहां पर, उनके वोल्टेज का लिखना है, तो लिख दो आप वोल्टेज। If you apply V, none of them should fail. So what is the voltage that you want to write across those people? तो दोनों को इंडिविजुअली लिख सकता हूं। एक टर्म मेरा आ रहा है निकल के x इंटू ये वाला टर्म जो करंट का टर्म है वो लिख के लग रहा है मुझे। एक टर्म लग रहा है x इंटू वी अपॉन एक्स प्लस आर प्राइम टर्म, और ये भी है साथ में दैट आई हैव टू कंपेयर दिस वैल्यू विथ 3, but the second voltage term is also there, and there also if you look into the current, that will be v upon x plus r prime, and I'll have a r prime. I'll compare them with 3 comparison. Let me see which inequality if I justify, then the problem will sort out correctly. So the problem is actually based on these equations where I will finally find out the inequality on V. Write a final equation on V. Now, as far as R prime is concerned, there are few things I can directly write. And we will verify it, don't worry. That part of the circuit which moves further, you know, take if all those people start behaving ohmically, what is your R prime? And then I will verify also whether my assumption is right or not. So calculation of R prime assuming ohmic character, what is that R prime? 3. अच्छा, √5 को 2.2 दिया हुआ है. So this is what you treated as a infinite grid. You got that value and that was in parallel with that value only. Okay. So you have taken, after the parallel connection, you got the value of x? 3. Okay. So your x in this problem then, R prime, as far as your calculation is concerned, you people are getting 3, right? Check, all of you can check, spend some time. Why x is coming there? X should not come because I am simply saying that all these people here, I am solving for R prime. No? And if all of them start behaving ohmically, then all the resistances are known as phi. So if all these people are phi, then I calculated this R prime value, which comes out to be 3. Right? That resistance is even lesser than what I expected. Is it fine? So no hassles for that. Because if he talks about these values, you can see the slope here di by dv is reducing. So dv by di is increasing. So he's talking about resistance which is greater than 5, and my resistance is coming out as 3. So my assumption is right. That much is fine. Now you do the calculations. मतलब ये तो क्लियर हो गया कि इस चीज में कोई प्रॉब्लम वहां क्रिएट नहीं हो रही जो आगे वाले रेजिस्टर्स हैं. So the only thing is to write these two equations correctly and check what are we getting. अभिषेक क्या वैल्यू आ रहा है? बस 2 को आप एक बाउंड्री कंडीशन पे सॉल्व कर दो जाके. मल्टीप्लाई द अबव इक्वेशन if you are solving into v upon x plus r prime and just solve for v. Just multiply the above equation by x and try to add them up. What is the value? एक बार चेक कर लेना, जो वैल्यू विच यू हैव गॉट आर प्राइम, it may be a different value. So I think you should check the calculation in the problem first. Four 4.6 के आसपास आ रहा है. The result that you are 4.2. The input that we have applied is around 4.2. देखो मेन चीजें देख लो, आप लोग कैलकुलेशन कर लेना, सीबी के अबाउट इक्विवेलेंट रेजिस्टेंस निकाल लेना, फिर आपको वोल्टेज अपॉन नेट रेजिस्टेंस की इक्वेशन एक मिल जाएगी जो करंट वाली है. इसके अलावा आपको ये ध्यान रखना है कि किसी भी एक बंदे से जो वोल्टेज है, दैट वोल्टेज शुड बी लेस देन इक्वल टू 3. नन ऑफ द वोल्टेजेस शुड एक्सीड 3. तो जो मेन लोग हैं उनको हम देख रहे हैं. सो व्हाट वी आर ट्राइंग टू से इज we are trying to ensure that this voltage is less than equal to 3. So all of them will be further less than equal to 3. This is also less than equal to 3. And if from these two we can write one of them less than equal to 3 such that the other one is justified, then our point is even simpler because you have already calculated R prime. Ideally, I should check all three of them. Ideally, after calculation of R prime, I should confirm that this value is less than equal to 3. This is also less than equal to 3. So this condition, and this condition. So for all these three inequalities to be simultaneously satisfied, if I can satisfy them, my purpose is. Current वाली बात भी हो गई, and all the voltages are also taken. V की वैल्यू आपको निकालनी. ऐसे तो देखें तो जनरली V और X के साथ ही है. So you can look into combinations also and solve and check which one is the maximum voltage which you can apply. If in exam you don't want to deal with inequalities, directly look into equality combinations. You have your R prime, you solve for two equalities and get the value of V and X correspondingly. Set of any these two and then maybe set of these two. And then you can verify also. है ना, आ जाता है. व्हाट इज द वैल्यू? 4.2. कौन कौन सा सॉल्व किया प्रथम? As R prime was 3 and you are saying as R prime was coming out to be less than X. तो R prime तो छोटा ही आ रहा था और वो आउटर डोमेन में जा रहा था. So this point I accept. So then finally what you got, finally your equations which you should need is V upon X plus R prime is less than equal to 0.4. This is the equation and the second equation is XP को देख लेते हैं क्योंकि वो तो फिर हो ही जाएगा. तो दूसरी ये वाली देख लेते हैं, XP upon X plus R prime. Reason is we are in this domain where the resistance is even higher. So this is less than equal to 3. These two equations we want to solve. What you have done, you have from these two, if you solve, you get the boundary value of V, which is approximately 4.2. So maybe solve for equality and check, you should get your answer, right? So fine, I'll finish off the class here and we will catch up with more problems with all of you tomorrow. So just this time of non-ohmic characters are quite important from JEE's perspective. Partially, 2-3 सवालों में हमने यही किया. ठीक है, कल मिलते हैं. ओके, टेक केयर स्टूडेंट्स, बाय बाय.